Good day. So now I'm dealing with the other half of the activities, right from number 8 until number 15. In the previous video, I dealt with number 1, from number 1 to number 7. And just before we continue, don't forget to like the video and subscribe to my channel so that you can receive more of this stuff. So for every question that I will post, just pause the video and attempt it, and then you can just play the video and just compare your solutions. So here we're told to prove the identities, and of course we'll choose the more complicated side, the left hand side. Proving the identities is more easier because the answer is already given, right? So now when we have tan squared, remember when we see this, we change it. We always change tan, sine squared over cos squared, right? Plus 1. And from here you can never say you're stuck. Remember how to add fractions. 1 is the same as 1 over 1. So 1 times cos is cos squared, right? 1 times cos squared is cos squared. And then when you multiply this stuff, it is sine squared. You multiply this, it becomes cos squared. And check how easy this was. Sine squared plus cos squared is 1, and we have over cos squared, which is exactly the same as the right hand side, so therefore it's equals to the right hand side. And we're done with this particular exercise. Alright, so now we have this stuff, right? So let's prove. So of course we choose the left hand side, and then from here we see tan again, so we know the first instinct is to change tan, so it becomes sine x over cos x, and then we leave the top and done. We can't even factorize it, by the way, because there's nothing to factorize there. And then from here this becomes sine x plus cos x all over this. We use the laws of adding fraction. It's the same as 1 over 1, so 1 times cos is cos, and then when you cross multiply that becomes cos, and then you cross multiply, it becomes sine. And then from here we now use the tip and times method. So when we use the tip and times method, this is exactly the same as sine x plus cos x all over 1. Now this is the same as, to avoid confusions, I'll just rewrite it. This is the same as over 1, while this part remains the same. I'm just gonna rewrite it. So notice what I did. This numerator is exactly the same as over 1, because if we have a over b over c, this a is exactly the same as a over 1 divided by b over c, right? So never get stuck when you say complex fractions. Whenever we have a numerator only, just make that numerator over 1, or just rewrite it as over 1. And then from here we can now tip and times. So when we tip and times, this is going to become sine x plus cos x over 1 times, you see the top, we will switch this, right? So this becomes cos x, and then at the denominator we have cos x plus sine x. Let me just rewrite this part nicely. So we have cos x over cos x plus sine x. But notice these are exactly the same, it's just that the order is different, right? Sine plus cos is the same as cos plus sine. X plus y is the same as y plus x, right? They're exactly the same. So since these are exactly the same, we can just cancel out, and then we'll be left with cos x, which is exactly equals to the right hand side. So here is the next exercise. So of course we choose the left hand side, and let's change that. So you see, we see tan. Of course you could add the fractions first, but just change it. So this becomes sine theta over cos theta. Then this is the same as 1 over sine theta over cos theta. So now we have a complex fraction again, so let's sort it out on the side. So this 1 over sine theta over cos theta is exactly the same as 1 over 1, right? Then this becomes 1 over 1 times, when you tip and times, cos theta over sine theta. Remember, we leave the first fraction unchanged, while we switch the second one. Then this becomes cos theta over sine theta. So that's what we write here. So on the next step we write cos theta over sine theta, and of course it becomes easy to add the fractions, right? It's easy now. So now this is cos theta sine theta, or you can say sine cos, up to you. Then when I cross multiply, this becomes sine squared theta plus cos squared theta. Then this becomes 1 over cos theta sine theta. Of course, we can rearrange it and say 1 over sine theta cos theta, and it becomes exactly the same as the right hand side. So we have it solved. So now we have to prove that this is equals to the right hand side. So now let's continue, because of course we choose the more complicated side, the left hand side. So tan squared is sine squared x over cos squared x minus sine squared x. This is exactly the same as over 1. So let's use the law. So then this becomes cos squared x. When you cross multiply, it becomes sine squared x times sine squared x cos squared x. And remember, this we can't go further here, right? Okay, we can, right? We can actually change this. We can change it to 1 minus sine, but I would just like to factorize, right? So let's factorize. So when you factorize, it's going to become sine squared x brackets. So when you divide it, it's 1 minus cos squared x cos. You divide sine squared and sine squared cancels out and gives you 1. You divide sine squared and sine squared cancels and gives you cos, right? So now we have over cos squared x. Now check this. 1 minus cos is sine, right? 1 minus cos squared is sine squared x over cos squared x. Of course, we could multiply it, but remember, we're trying to make it the same as the right hand side. So this part, sine squared over cos squared, is tan squared. So here we have sine squared x, here we have tan squared x, and then it immediately equals the right hand side. So there we have it. Or if you used another method and you ended up having sine 4x over cos squared x, you could just split it, right? When you split it, it will become like this, and then you eventually divide, you eventually have this. All right, so here's the next one. Of course, you can pause and attempt, and let's compare. So now this tan, of course, that's our first thing, the first thing to change. So because it's our left hand side that we're choosing, right? And then now this, use the laws of adding fractions. So this becomes cos x times 1 plus sine x. And then when you cross multiply, this is cos squared x plus sine x times 1 plus sine x. All right. So yeah, cos squared x, and we had this stuff. Okay, cool, no problem. So now what we're gonna do is, so we're gonna distribute, so this becomes sine x sine squared x all over cos x 1 plus sine x. So now this gives you 1, sine plus cos, right? This 2 gives you 1. Then this sine remains, so sine x over cos x 1 plus sine x. And then you would realize that they're exactly the same, this, right? So since they're the same, it cancels out and it gives you 1 over cos x, which is exactly equals to the right hand side, because see, we have it the same. And here is number 13. Of course, you can pause and attempt the video. All right, so now our first instinct is to just change tan, of course. So when we change it, this is sine cos. Okay, this is sine over cos, right? Tan is sine over cos. And then this is sine squared x. So from here, this becomes adding fractions again, or rather subtracting fractions. So you know what to do there. So when you multiply, we will have cos theta, right? And then when you cross multiply, this is sine theta. You cross multiply, this is sine theta cos squared theta. And then we still have the main denominator down there. Okay, if this part confuses you, you can just always repeat it, right? You can just repeat it. So then we have this stuff, right? So we can use the tip and times method, but before that, let's see if we can factorize. Okay, let's just use the tipping times method right away. We could do it. We can do anything, right? So let's just use the tipping times method. So this is a fraction over a number, but this number is the same as over 1, right? So let's cross. Let's do the tipping times method. So this becomes sine theta minus sine theta. There's many ways you can solve it. You can even choose to simplify this, up to you. But I will simplify it later on. Then this becomes times 1 over sine squared theta, right? And then from here, now let's when you can see there's nothing that cancels out, right? So now what we do is we just multiply along the same line. So this becomes sine theta cos squared theta. Then this is what? This is over cos theta times sine squared theta. Alright, so now let's continue. So we can see there's common factors there because we can't add them, right? But we can see there's a common factor, so we can just factorize it. So let me just do that step up here. Okay, of course we remember that the right hand side will become tan, right? So when we factorize, the common factor is sine, right? The common factor is sine. Then when we divide, we'll have 1, and then this is gonna be minus cos squared theta. Then all this we have it as, let me just rearrange this. This is gonna become sine squared times cos, and then from here this becomes sine theta times, notice this becomes sine squared theta over sine squared theta cos theta, and bang, this 2 of course cancels, and then we'll be left with sine theta over cos theta. This is equals to tan theta, which is exactly equals to the right hand side. Before I erased it, it was tan, remember? And here is number 14. So we have got this identity that we have to prove. So of course we choose the complicated side. So our first thing is to just change the tan. So we're gonna have sine squared x over cos squared x. Wow, quite easy. We can already see that this 2 will cancel, and then this becomes sine squared x over sine squared x over cos squared x. This is quite simple. So this is exactly the same as over 1. So this 2 cancels, and then now we'll be left with sine squared x. Let's deal with this part on the side. So of course this is the same as sine squared over 1 divided by sine squared over cos squared. And remember, we changed the division sign into multiplication, and then we just switch the second one, and then this is that. So then this 2 cancels and we'll be left with cos squared. So it means this part is cos squared x, and this is exactly equals to 1. It was quite easy to solve it. Right, so now let's prove this one, right? So of course the left hand side. So we use the laws of adding fractions. So when we multiply this stuff, this is gonna become 1 minus sine x, 1 plus sine x, and then of course this is gonna be 1 plus sine x. This is gonna be 1, okay, this is gonna be plus 1 minus sine x. Wow, this is easy. This is easy. Cause check, this 2 cancels, and then we'll be left with 2, and then the only option will be to multiply. It will be that. If you look at the bottom, you realize it's the difference of 2 squares. If you don't realize that, no problem, just multiply. We will eventually have cos squared, and then this is exactly equals to the right hand side. So this brings us to the end of the video. Don't forget to like, comment, subscribe to the video, to the channel rather. Yeah, so thanks guys for your time. See you.